Good morning. I am D. Sengotian, Assistant Professor of Physics, SNS College of Technology, Coimbatore. In this video, we will discuss about coordination number and packing factor of simple cubic and BCC. Then next equation shows that D equal to A by root of h squared plus k squared plus L squared. So D it means distance or interplanar distance is equal to A equal to lattice constant then divided by root of Miller indices value HKL value. So A equal to lattice constant, it means length in x-axis or y-axis and z-axis, and also HKL value, Miller indices value. We all know that Miller indices to find out the direction of the plane and the reciprocal. Finally, the value reduced into minimum number or minimum value, that means Miller value. Then the diagram shows that in crystal lattice, axial length and interaxial angle playing the important role. So we all know that for example in cubic system A equal to B equal to C and also alpha, beta, gamma all are equal and also equal to 90 degree. So based on this axial length and interaxial angle, we have 7 crystal systems and 14 possible types. Then next we will discuss about introduction to coordination number and atomic radius, then determine the atomic packing factor of simple cubic and body center cubic, then uses of atomic factor in real world applications. Then the next question is about why we need to calculate the atomic packing factor. So the atomic packing factor value formula is equal to volume occupied by the total number of atoms present per unit cell and also divided by total volume of the unit cell. So in crystal lattice, we have to find out the total number of atoms present per unit cell and also coordination number of that particular lattice point or atom. Then finally find out the atomic radius and the packing factor. So packing factor playing the important role in crystal lattice. So in crystal, based on the axial length and interaxial angle and also number of atoms playing the important role in properties of crystal materials. So we all know that in crystalline nature, atoms arrange in a regular manner and also crystal materials have directional properties. Then next title is about important lattice parameters in a crystal. So these 4 parameters are important to find out the crystal lattice. The first one is about number of atoms per unit cell. Then next coordination number, that means nearest lattice points. Then atomic radius, half of the distance between any two nearest atoms. Then finally find out the atomic packing factor value and also packing density. Then next, this diagram shows that the important lattice parameters in a cubic lattice. For example, simple cubic lattice, the first diagram shows that 8 corner points. So each and every corner point shared with 8 unit cell. So finally 1 by 8 into 8 equal to 1. Then value of number of atoms per unit cell present in simple cubic is equal to 1. Then second diagram shows that coordination number, then particular lattice points surrounding nearby lattice points. That means nearest neighbor lattice points. So finally the value of simple cubic equal to 6. Then atomic radius, half of the distance between any two nearest atoms. The lattice constant value equal to A. So finally R equal to A by 2. Then the ABF value, find out the ABF value. We have to identify the total number of atoms present per unit cell divided by total volume of the unit cell. In simple cubic system, number of atoms present per unit cell equal to 1. Then finally ABF value equal to 0.52. That means 52% of the volume is occupied by the atoms and remaining 48% is vacant. The next important lattice parameters of BCC, body center cubic system. So we know that body center cubic system, extra lattice point present per unit cell, that means BCC atom. Then in BCC also 8 corner points, each and every corner point is added with the 8 unit cells. So finally answer equal to 1 by 8 into 8 equal to 1. Then plus BCC atom 1. So finally 1 plus 1 equal to 2. So total number of atoms present per unit cell in BCC is equal to 2. Then atomic radius of BCC A root 3 by 4. Then coordination number of BCC equal to 8. The particular BCC atom surrounding with 8 corner points and also any corner point surrounding with 8 BCC atoms. So finally answer equal to 8. Then ABF value of BCC atom 0.68. So we all know that ABF equal to total number of atoms present per unit cell divided by total volume of the unit cell. In BCC, total number of atoms equal to 2. So 2 into 4 by 3 pi r cube divided by A cube. Finally the value of BCC equal to 0.68. That means 68% of the volume is occupied by the atoms, then remaining 32% is vacant. So these are the important lattice parameters of simple cubic and BCC system. So in cubic system we have three possible types: simple cubic, BCC and FCC. So these possible types finally find out the number of atoms per unit cell in BCC, simple cubic and FCC, and also find out the coordination number of these parameters and coordination number, then atomic radius, finally find out the AB packing factor of simple cubic, BCC and FCC. So based on the lattice length and interaxial angle, we have to identify the possible types. And for example, cubic materials have three possible types: the tetragonal, rhombohedral. We all have different system and also different possible types. For example, in hexagonal there is only one possible type, simple hexagonal. So these all are the important lattice parameters in a crystal.